This is TID 16, component ID 80. It's the after-catalyst oxygen sensor, B1S2. It's the rich voltage test. The CID 80 indicates we have a minimum limit. Now the PCM monitors the after-catalyst oxygen sensor voltage during periods of rich fuel control and stores the highest value. Now the values you're going to see are not converted into measurement values. Use the data as a relative indication of performance. We'll use vehicle data to show the real results. We're going to look at some scan tool readings on both a PC and traditional scan tool. Now here's a couple of them on a PC-based scan tool, two different vehicles. We notice we have two different failures on 16. We have seen this failure pattern on high-mileage JTAG vehicles during very cold weather where warm-up takes longer than normal. We think we probably have old sensors. We know that, but it's not setting a code. So you shouldn't re-overact to this. It may be a problem with the warm-up situation. Now traditional scan tools look like this. We have a minimum limit of 17. We have a measured value of 3. We have failed. This is the same type pattern we were looking at earlier. Maybe a product with cold sensors. Now in the traditional scan tool, you're going to have to scroll through all the screens. They're easier to read. There's more information here. It looks easier laid out, but you have to scroll previous or next to see all the data. Now, we need to identify some of these failures, and we're going to see how to do this using lab scope patterns. Now, we're going to use lab scope patterns to direct us to a problem area. Now, we want to emphasize we cannot always identify the exact cause of a failure from a lab scope pattern, but we can verify mode 6 information. Let's go look at some of this information as it comes out a lot. As we look at this pattern moving about, the red trace is the one of interest. That's our after-catalyst O2 signal. It has some activity right now, but we're going to try to find a way to get more activity. To do that, we're going to do a snap accelerate test. Here's the results of that snap accelerate test. Fuel control went rich first. This is a necessity to make this test work. Next, we're going to look at the after-catalyst O2 sensor, and it's here. Now, it went rich also. We've got to look at the voltage scale to see on the right exactly where we are. We're at 1 volt. So if we look back at how high the red trace went, we see it reached 1 volt. This is the type of testing we can do. Now, remember, the fundamentals to make this test work is that fuel control must go rich before the after-catalyst can go rich. The snap accelerate test accomplishes this. We can do this type of testing and verify it. Now the PCM can do this type of test, but it changes it only briefly and does the same thing. So use this to verify mode 6.